Okay, so the instruction was that you had to get the resultant in the particle B2. Not the particle, the charge B2, which is this one. Okay? Well, I don't know. Eh, Bueno, más o menos se mira. Okay? Bueno, so this is what you had to do to get and analyze all the possibilities. So for example, the force that I called force 1 was this one, okay? And it's a force between the charge A1 and the charge B2, okay? Because the two charges are different, they have opposite kind of charge, so we have an attraction force, okay? The particles want to get closer. So the direction of my force comes in this way. This is the analysis that I do for the first force. The second force, I took it from here. I have two forces, the two of them are negative, and because the two of them are negative, repulsion occurs. So these charges want to be apart from each other because we have repulsion. My third force, I get it between these two particles. Because they are opposite charges, I have attraction. My third force, my fourth force is going to be this one. And since they are opposite charges, they're going to be attraction too. Okay? Now, with this, you have the sketch or the free body diagram of your charge in B2. Okay, that's the way the forces should look like. Okay, now what happens then? Because you need to get the forces by using Coulomb's law, that means that you need to know the distances between all those charges. Okay, some of them are given and some others you have to get it. For example, those forces that are diagonal forces or forces that have angle, you need to get the Pythagorean theorem for them. Okay, you need to get the hypotenuse for them. So take a look. Between these two, I have to get the hypotenuse. So this is this procedure right here. And I get the hypotenuse by raising to the second power the y and the x, the vertical distance and the horizontal distance. Once I do all this procedure, I get that my diagonal distance is equal to 0.43 meters. Okay, which is this one right here. And because I apply the Pythagorean theorem, I'm also going to apply the formula to get the angle. Así de un solo, ahora vamos a ir avanzando. Like with this you get the distance and with this you get the angle. Entonces usted saca, you get this distance, okay, and you get this angle in that procedure. The angle that I got here was 20.56 degrees. Okay, now that I finish with this diagonal, I get the second diagonal. For this diagonal, for this hypotenuse, I have a vertical distance of 0.2 meters and a horizontal distance of 0.40 meters. So right now, what I do is I get the hypotenuse with all that information. I get the hypotenuse and it gives me 0.45 meters. I also calculate the angle, okay? I know now this distance and I find this angle. This angle, by the formula, I obtain 26.57. 26.57 degrees. And then for the rest of the distances, for example, for my force A to B2 is this distance, and this distance is 0.4 meters. And for the force B2, B3, the distance between them is this distance right here, and that distance is 0.20 meters. Those are all the distances that are in the exercise. Now, in this part of the problem, do you have a mistake in this part? Because if mistake is from here, in your quiz will be 0. Because if your data is incorrect, everything else is going to be incorrect. So be careful on this part. This is the most important part. So you have to do the sketch very carefully. That was a super F, the comment that you sent me. Okay, now that you have all that, just remember, microcoulombs. Micro means times 10 to the negative 6 power. So if you have 8 microcoulombs, you will have 8 times 10 to the negative 6 power coulombs. That is also very important. Once that we have done all this, we continue with the part of calculating the electric forces. Now take a look the way I named them. For example, the force A2, B2, es la force A1, B2, sería la fuerza entre A1, A1 es esta, y B2 que sería, esta sería B2, pero B1, pero no existe, entonces B2 sería esta. So, in my formula, I will include the values of the charges. Esta sería una de mis cargas, esta sería la otra carga, 8 and negative 8. But the negative doesn't really matter. Okay, you will see the reason why. So take a look here in my calculation. I have A1, B2, and here I have the data. This value right here is Kc, and this is the distance between them. Remember, it is the first diagonal. It is the first diagonal right here, and that distance gave us 0.43 meters. So you get all the forces, and here I got the answer negative. It doesn't really matter if you put it positive, because in the end, when you put all the data in the table, this is what really matters, okay? This is where you include the symbols. Here you can write them just because. But remember, the sign matters in this part. So you get all the forces. You get the second force, that is between A3 and B2, okay? And A3, B2 is from column A, the third one, and from column B, the second one, okay? So you're going to include these two charges, the charge of 10 and the charge of -8. And the distance, this is the second diagonal, so that distance is going to be 0.45. So here, the charge of 10, the charge of -8, and the distance of 0.45, and of course, Kc. You apply the formula, and you get this answer. As I told you, it doesn't really matter if you include a sign or not. Here, it doesn't matter. I do it because I know you do it, but it really doesn't matter, okay? So once you have the second force, you continue with the third force that says B2, B3. The force B2, B3 are only this one. This is my B2 and this is my B3, okay? So the force that I'm calculating is exactly this one, B2, B3. So the charges to consider are 6 microcoulombs, -8 microcoulombs, and the distance between the two of them, which is this distance right here, which is 0.20 meters. So you will use all this information in the formula. The charge of -8, the charge of +6, the distance of 0.20, and of course Kc. You get this answer. I hope you are getting it in your calculator just to check if what you get is right. My number 4 is the force between A2 and B2. A2 is this one, B2 is this one, okay? So the charges to consider for this part is -6 microcoulombs and -8 microcoulombs. The distance between those charges is this distance, which is actually 0.40 meters. So you will use all this information in the calculation of the last of the forces. So you have -6, -8 microcoulombs, the distance of 0.40 meters, and of course Kc. In the end, the answer I obtained was 2.70 newtons. In this second part of the exercise, do you have any doubt that you can send me through a message or you can ask me in this moment? Bueno, if there are no doubts, I will continue. After this, okay, let me see, I got a message. Yeah, it's from B, it's taken from B. In the instruction that I sent was that you had to get the resultant on B2. And this is B2. So yes, basically everything is going to be measured from this, from B. So once you have all these forces, you take your sketch apart of B2. Remember that this is B2, okay? And now I will include the arrows, but also the values that are in the arrow. So here I put the values. as you can see here, my values are positive. The reason why those values are positive is vectors have a positive magnitude. Vectors just tell you, the number in the vector just tells you how large the vector is. The sign matters here. This is where the sign matters, not above, okay, not in the sketch. In the sketch, just include the value of the vector, the angles, if there are angles, and as you can see, here I put the first angle that I got from here, okay? That's the first angle. It says angle between A1, B2. Angle between A1, B2, okay? So this is the angle that I'm getting. Also, this one is the second angle that I got, okay? And I put all the values in it. Once I have all that, I start sketching, I start drawing my table of components. Remember, my table of components have vector, x component, y component. And as you can see, to be organized, but that's my personal choice, to be organized, I name the vectors like 1, 2, 3, and 4, just to keep my procedure organized. I totally recommend you to do that. So here I begin with my vector 1, okay? 2, 3, and so on. In my first vector, I have this arrow and this angle. And this is exactly what you see here, the arrow and the angle, okay? So, I take the vector and I analyze the vector and I say, this is my x component of the vector and this is my y component of the vector. My x component is going to the left, my y component is going up. Because my x component is touching the angle, I'm going to be using cosine. And because it is going to the left, I'm going to have my negative answer. My y component is in front of my angle. Here I have my angle. Here I have my angle and my component is right in front. Because it is in front, it's going to be using sine. And because it's going up, it's going to be positive. I introduced this in the calculator and I got negative 291 and positive 109. Is this vector good for any of you? Can you send it to me in the chat? Is the first vector correct for any of you? Okay, here's the thing, and that's why I'm asking. In the end, what I evaluate in the quiz, what I evaluate in the quiz, I will evaluate distances and angles of hypotenuses. Okay, for example, if this is good, if the two are good, you can get plus 1 or 2 points according of what you have good. I also evaluate the forces with or without the sign, okay? So imagine here I have 4 points 4 more points, and here 1 or 2 points. I'm going to get 1 point for that part. So far we have 5 points, and the rest of the 5 points are the table. How I evaluate the table? 1 point each vector. 1, 1, 1, 1. And then for these two values, 1%. Sometimes I evaluate this as 0.5 each. Okay. Which in total it gives me 3.5, for example. Or I can take this away and just leave the 3. And 3 plus 4 plus 1 gives me 8. And the last part, I put the remaining, okay? For example, in this case, 2%. That's how I evaluate. Sometimes you get everything incorrect from the step 1. And if the step 1 is incorrect, everything else is also going to be incorrect. So the chance for you to get a good score is reduced when your first step is incorrect. What I'm trying to say is, I'm not going to say avoid committing mistakes because that's the purpose of it, but be focused, be completely focused when you are working on this kind of exercises. More or less, I already showed you more or less how I evaluate. Sometimes even if you don't get the 1% here, maybe here you get 0 because you got everything incorrect, but because you have these two data correct because it's given, you can have 2 forces correct, so you can have 2 points. And maybe one of these forces give you right. So maybe you can get 3, 4 points even if it is incorrect. But that's not the purpose of it. The purpose is that you can get it right. Okay? That's the purpose of it. In case of that you were wondering how I evaluate, that's the way I do it. And that's why I was wondering how many of you got right the first vector. Once you're done with the first vector, you can start working with the second vector. This is my second vector, okay? And it has an angle, so that means that it has a component to the left in x and going down in y. So here, in x is going to the left, so it's going to be negative. And because in x is touching the angle, it's going to be using cosine. In y, as you can see, is in front of the angle, so it's going to be using sine. And because it's going down, it's going to be negative. Apply the formula in the calculator, and those are the two values that you should get. Did you get the second vector right? Did you get the second vector right? See what I'm saying, okay? If I was evaluating this homework, most of you would get between 0 and 3% if I would be evaluating this homework. So that's why I'm showing you step by step how I did it. If you want to reinforce vectors, I have many videos from last year and some others from this year where I explain vectors. But that is a topic that you supposedly know already because I explained it to you last year. The third force is the one that is coming down. Because it's just coming down, it's just moving vertically. So that means that in x is going to be 0 and in y is going to be the same value as the vector but negative. Does is the third vector good for you? You can send me the message now. That is good. If the third vector is incorrect, it means that you couldn't even get the electric force correct by using Coulomb's law. And that is a very, very simple formula. So you need to be careful, very careful. Now, I will focus on the last force. The last force, as you can see, is this one. It's going to the right, and it's 2.70 Newton. So, I draw it here. And it's just moving horizontally. Therefore, in x, it's going to have the value, but in y is going to be 0 because it's just moving horizontally. Once you have all your answers, you can get your result in your calculator by doing the vertical addition of each column. In the end, you can get that x is negative 3.39 Newton and y yes, the 4 is going to the right instead of to the left. The reason is, take a look, it's going to the right, okay? Why is it going to the right? Because in the sketch, this is the force that is coming from this charge, okay? This charge is a negative charge. The charge in B2 is also negative. So when I have two charges that are negative, that means same kind of charge, I have repulsion. And when I have repulsion, that means that these particles want to be as far as possible. That's why this force number 4 is going to the right instead of to the left. Now, if, for example, this charge was positive, then yes, they will be attracted. So the force will be going to the left. But because they are the same kind of charge, they are repelled. So you add all your answers vertically and horizontally, and you will get these two answers. Take a look. The two answers are negative. Now, in the resultant calculation, you apply the formula, then you get the square root of your answer, and you get to be 11.79. To know if you did it right, you have to see that this number must be bigger than x and y. And as you can see, 11.79 is bigger than 11.29. So we don't know if it's right, but at least it makes sense. And then in the last part, what we do is we apply the formula for the angle. And we say our tangent of y divided by x, and you get your answer to be 73 degrees. Once you have all this done, you continue to sketch the resultant. And take a look to what I did. Take a look, I took many pages. Each picture is one page. What I'm trying to say is that sometimes it is totally worth it to use a lot of pages just to be organized. So now in the last page, I leave just the resultant, the sketch of the resultant, and I got small values, okay? So what I did is just rounding. Negative 3.39, I rounded to negative 3.4. Negative 11.29, I rounded to 11.3. And 11.79, I rounded to 11.8. So when I did the resultant, because they are the two negatives, I'm going to use the quadrant negative x and negative y. Okay, so in x, I got negative 3.34. So it's in this direction, negative 3.4, more or less. And in y, I got 11.3 negative, so that means that it's going down. 11.3. Those are my x and y. This is y and this is x. And my resultant, so what I do is I make a dash line, okay? And then I cross with the dash line here. And the point that two dash line intersect is the size of my resultant. So my resultant comes from the origin, bueno, to my opposite corner. Ahí no es, espérense, me movió esta cosa. Desde el origen hasta la esquina opuesta. And there I have it. I have my resultant over there. And if I take my protractor and measure this angle, it's going to be around 73 degrees. I'm going to send you the pictures in a single file for you to analyze each step and that you can zoom in better, okay? And I will assign you another homework for you to practice. Because if I do the